One, and we're on air.
Thank you, Paul. Okay, so let's do a quick review of this stuff, and then we can dive right into the problems. All right, we are going to introduce our new best friend. Did we name the hexagon? Anyone name it? The other class? Peter. We are going to introduce our new best friend, Peter, into our old best friend. Who's our old best friend? The unit circle. The other class named him Dot. Does anyone have a better name than Dot?
Emirati, so we can have Peter Emirati.
Emirati. Okay, so Peter meet Emirati. That's a little weird. Okay. Anyways, so what do we remember about this unit circle thing going on here?
Diameter 2.
We've got a triangle here, right? This is always, radius is always 1. Okay? And as I move it around, this is no specific angle. In this triangle, this represents cosine, right? And this represents sine. Okay? Now, what do you guys remember about proportional triangles? Do you guys remember this stuff at all?
Yeah, you can like set out proportions. We have two different triangles.
Yeah.
Outside or something.
So in the red triangle, I'll do this in red, we have, I'm going to use little a, little b, and little c. And in the big green triangle, this might come out orange, I'm going to use big A, big B, and big C. So how do I set up a proportion? Given that I know these three sides of a little triangle, oh, one thing I immediately know about the big green triangle. What's the length of this side here? 1. Fantastic. Okay? So I'm going to use what I know here to find the missing two sides, B and C. So, what can we do to find B?
Set a proportion.
Set up a proportion. How about big B to little b? Equals what? What should we use? What do we think? How about big A to little a? Okay, what's big B? We don't know. We want to find it. What's little b? Sine. Equals what? What's big A? 1, good. And what's little a?
Cosine.
So what's big B? Paul, what should I do to both sides to solve for B?
Not sure.
Multiply by cosine.
Cosine.
Multiply by sine. Good, Andre. And I heard someone in the back row too, so very good. What do I get?
Sine over cosine.
Look familiar?
Tangent.
We've been doing this stuff all along, but we never quite figure out why these things are called what they're called. This side is, in fact, sine over cosine. It is tangent. And remember from geometry what we would call a line that touched the circle in one place? A tangent. Fantastic. Very good. You guys take a minute, try and solve for C. See if you see something familiar. What do you think, Sasha?
I'm looking at it.
That's the equal C.
Of course, for confidentiality reasons, I've made up names for each of you. That's why I'm not at all calling you by your real names, right?
Right.
Right. Sasha. Okay. So give it a shot. Write it down.
No, how would we set it? We would set up big C over little c.
Perfect. You got it.
Equals either or.
Yeah, take your pick. Well, so where's your original proportion? What did you set up? What did you use to start? C to big C to little c? Is little c cosine?
Yeah.
Little c is not cosine. Little c is, I was going to use x, y, z, but little x's and big x's look the same.
Little c is a big C.
Okay, so let's try this. We're trying to find big C. Big C to little c equals
0 over 1.
equals, what are we going to do?
Oh, equals A over lowercase.
Big A over little a? Okay, big C is what we want to find. What's little c?
1.
Big A is what?
1.
1? That's a good choice.
Cosine.
So what is C equals? 1 over cosine. What do we call that, Jen? Secant. Thank you, Jen. Sasha, whatever your name is for the day. Okay? Yes. This big green line here is secant. Apologize for the smartboard there. And anyone remember from geometry? This was a tangent. And what was a tangent? Something that touches a circle in one point. What's something that cuts through the center of the circle? It's a secant line. And this one's a special secant that actually goes through the center of the circle. It doesn't have to go through the very center. So right there, comes straight from there. If you draw a different triangle, you'll get cotangent and cosecant, but it's just the other way around. Same ideas. So from this picture, up until now, we have said that, that on the hexagon, we know where sine squared plus cosine squared equals 1 comes from, right? Let's clear this whole mess. Sine squared plus cosine squared equals 1, right? But what about this? What does the Pythagorean theorem tell us about this? Plus equals? So that's where we get the other part. That's where all this stuff comes from. You've got, this guy gives you here, gives you we've got tangent squared plus 1 equals secant squared. So that's why this all works. And the third one, we're not going to draw that, but you got to believe me that 1 plus cotangent squared does indeed equal cosecant squared.
Each one equals the hypotenuse.
Each one, there is a...
In the triangle, that would be the hypotenuse.
Yes, in the third triangle, we'll have cosecant will be the hypotenuse. And I don't want to get this confused. I can draw you another picture tomorrow, but I think one's enough for today. Okay? So that's where those things come from. This hexagon did not fall down from above and suddenly give us these magical identities. You can also verify that last one algebraically if you want. Okay? So now that we know where these guys come from a little better, who wants to do some problems?
We all do.
Last period, I know. Wake up. We all want to do some problems, right? Okay. The one that I'm seeing everybody's having trouble with, it looks like, a lot of you. What is it? Paul, the one we were just talking about.
Oh, 31.
Yeah. Cosine plus... Okay, so for the first time we have two variables. Plus or minus, Paul?
Minus cos y over sine x plus sine y plus sine x minus sine y.
Sine plus?
Sine, yeah.
That's a long problem.
No, this is 31.
It's the one Paul wants to do. Okay.
Plus sine x minus, no, sorry. Sine x minus sine y over cos x plus cos y.
Okay. And we want that to equal something, I assume?
Equals
0. We want to show this. So which side are we going to pick?
Left side.
Yeah, not much choice here. All right, so a lot of you looked at this and then left it blank. What is the only thing we can really do here?
Common denominator.
Common denominator, good. So what am I going to have to do to get a common denominator? Yes, it looks a little messy.
Cosine x and cosine y.
I'm going to have to, so I've got this guy here. So what do I want on the bottom? I want this on the bottom too, right? So I can just multiply the bottom by that, right?
So top two.
The top two. Good. Okay? Everybody go ahead and do this. And I promise you that it will work out in 2 steps. You're going to have to do the other half as well. Everybody can do this. I have faith in you. And think about Dondre's question. It was a good one. Should we FOIL this?
I don't want to.
You don't want to. Does anyone have
Difference of square.
difference of squares? Save ourselves some trouble. And don't even worry about multiplying out the bottom. Save yourself some trouble. Take a look at what you guys are doing. Good progress. What should you multiply? If I multiply cosine x plus cosine y times sine x plus sine y, don't I have to FOIL or something? Do the other half. You don't even have to touch the bottom, I promise. But you got the top good. Well, halfway. All right, so I'm not even going to worry about the bottom. What do I get on the top here?
Square x
Good.
and cosine square y. Plus sine squared x.
Good.
Sine squared y.
And I tell you what, I'm not even going to worry about the bottom. I could write it out and just say cosine x plus cosine y times x, sine x plus sine y, but we want it to equal 0, right? Let's be smart here. We don't have to do any more work. As long as the top is 0, we don't even really care about the bottom being 0. I'll write it out for good measure then. Okay? But we absolutely do not have to multiply it out. So a lot of the times it's a good idea not to write it out. But if we did, Sasha, remember, you'd have to boil it out and get 4 pieces. All right, we are surprisingly close, actually. Does anyone see what I could do next, Paul? Well, what do you see up top? Do you see any identities? Perhaps our favorite identity? 1 and 1. Good.
Yeah.
What do you see 1 and 1?
Cosine x minus sine plus.
Well, let's go, so this is going back to your algebra skills. Let's just make it easy. Let's group like terms. Why don't I put the x terms together? Smartboard is not happy today. Right? Those are my x terms. What's up next? And those are both minuses.